So number two is a lot like number one, but three is a little bit different. So I'm going to show you how to set it up. I'm not going to do it for you, but if I'm solving for a temperature change, right, all I do is a little bit of algebra from the equation above, right? So change in temperature is going to be my Q divided by a mass and a specific heat, right? That's how I would get it if I was just using the equation. But I want to show you how to write that out with dimensional analysis. So if I started with that calorie, that's my Q, right? I'm going to divide by a mass. I'm going to divide by what I would divide first by is my specific heat, because that's going to give me a calorie on the bottom, gram degrees Celsius on the top. And all I know when I'm doing problems like this is I need those calories to go away, right? I want a temperature answer. I want the degree Celsius. So I also need the grams to go away, which means that my next step should be to divide by a gram, right? Now, like I said, you can just use your brain to figure out that this how this is going to work. I bet on that last mark there. Get rid of those. I have to put the number down here, number up here. I'm still going to take, right, Q and divide by mass and specific heat. I just prefer to show my work this way because it's a lot easier for me to figure out what to do without having to memorize anything, right? Just use the units that are given. Again, this is aluminum that we're talking about, so I am probably going to have to find the appropriate specific heat up here for aluminum. But set up your work like this, you should be able to come up with an answer. Whereas if I want to solve for grams, this problem, I'm solving for mass. Mass should be Q divided by a specific heat and a change in temperature, right? Again, if I'm just setting this up, it should make sense. If I'm given calories, I should divide by my specific heat because it'll have calories on the bottom. To get rid of those calories, I'll be left with grams and degrees Celsius on the top. This time I want a gram answer. So it makes sense for me to cancel this degree Celsius with something down on the bottom, right? So I'm going to put my temperature change, which happens to be like a positive 50, right, on the bottom. And again, the appropriate specific heat needs to be used here. So I got to look up, just trying to cancel that Celsius, and I missed twice. There we go. So get rid of that degree Celsius. I need an appropriate value for right here. So I'd have to look up above, and this is water we're talking about, and it's liquid water because it's 25 to 75. So that should be this value right here because this is the liquid version of water. This is solid. This is a gas, right? So it matters what state you're in. But plug in that value of 1 right there, right? 1.00 calories per gram degree Celsius, and you can solve for your mass. Finally, if you're solving for a specific heat should be equal to Q divided by the mass and the temperature change, right? Which should make sense because actually the unit for a specific heat is calories divided by grams degrees Celsius. So that's exactly what you do. You don't need like railroad tracks for this. You just put your calorie number on top, right? Number of calories, divide it by, and put the number of grams that you have, put the number of, or the degree Celsius, the change in degrees Celsius. You got to use the 45 and 20 for that. But once you plug those numbers in, just divide and you're good. Should be pretty easy.